Okay, I'll start question 1. Question 1 is a PCI 2010 questions. What you are actually given is very simple. A curve that is actually defined by a parametric equations. Okay. Now one thing is this, some extra things that I hope you can actually take down for yourself. And the question actually asks you to actually sketch the parametric equations, okay, of the curve. You should know that you will actually go to your GC and then actually change your mode to parametric, correct? But one thing to take note please, okay, because you will reset your GC at the start of the exam, when you actually change to parametric and later when you actually plot your equation into the x and y, remember before you actually press the graph button, please go to Windows and check your T minimum. Once you reset your GC, your T minimum will always go to 0. It's confirmed. Okay, so remember this. That means if again I repeat, if the question wants you to sketch the parametric equation curve, okay, remember you will restart your GC at the top exam. So when you actually set your mode to parametric, key in the equation, do not key in the graph, do not press the graph button first. Okay, go to Windows and check your T minimum value. Because once you reset your GC, your T minimum value will always go back to 0. And a lot of times your parametric equations will take negative values. So very simple, change it to a negative value. Okay? These questions do not need you to actually sketch a curve. So this is basically some extras for you. So the first part is to actually show the tangent to the curve at any point with parameter t. Okay, so this one very simple. Just need to go through you first before I actually do the steps. To actually get tangent very simple, you actually need to get dy dx. Correct? After you get dy dx, you just use the finding the tangent, the equation of tangent formula, and then you just do it. Correct, right? Okay? And then how to actually get dy dx if you actually have a parametric equation? Very simple. You go and differentiate the x with respect to the parameter, in this case t, so dx dt. And differentiate y with respect to the parameter t, dy dt. So dy dt, dx dt, then you just know what to do. To me, I always take it as dy dt divided by dx dt, giving you dy dx. Alright. So with this, for those who have tried the questions, I think you all will actually do the differentiation. I just show you some of the steps. Now, for your differentiation, usually you need to do quotient rule. It depends on question. Because for some of the questions, quotient rule, if you apply it, it's actually easier. However, please take note that when you actually apply quotient rule, right, because of the negative sign, if you actually do something wrong, right, it will go wrong. So at least have something to memorize, like how do we actually think about quotient rule. For me, it's very simple. Usually, I'll just follow a certain thing. It means I will square the bottom, hold the bottom, differentiate the top, minus hold the top, differentiate the bottom. Okay, you can do it your way, but take note. Okay, the way that you remember must be correct. Because of the way that quotient rule works, there's a negative sign. If you remember it wrongly, okay, you will have a negative issue. Have this? Okay. So dy dt. Okay. Alright. So you all actually get this differentiation. Any problem with this? Any issue? Students? No issue all? So no issue. The thing is that if you actually do the simplifications, I think for the top, you actually get this. Okay, and after this, to actually get your dy dx, usually for writing, you actually write it like this. So The last row, can you all see? Alright. So you all will actually get this for the dy dx, but the question is not over yet. Because after you get the dy dx, you know that you actually have to use a certain formula to get the equation of tangent. You all have a few equations to work with. Some of you actually use y equals mx plus c, correct? Then some of you actually use y minus y1 over x minus x1 equals to the gradient. Okay? Depends on your preference. For me, I will actually use the y minus y1, which in this case, what is so-called your y1? Is actually the point that you're actually looking for the tangent. So if you actually read the question, the point that you actually have, the y coordinate is just basically the parametric expression. Correct? You know what I'm doing on? This formula that I'm actually doing is, if you want to actually know it, y minus y1 equals to m bracket x minus x1. Okay. The reason why I don't like to use actually y equals to x plus c is because when you actually do y equals to mx plus c, later you have to sub in the 2 points to actually get c. Sometimes in terms of working, it tends to get a bit confusing. Okay, so if you actually do this right, later you can just open up and then just shift things over. The algebra manipulation is sometimes a bit easier. Again, it depends on your preference. And so on? Yeah. Any issue with it? So if you have no issue, the questions I will leave it up to you to simplify until the expression that the question is. Anyone have issue with this? So the concept is very simple, dy dx, then use y minus y1 equals to m x minus x1. No problem. One thing is this. A lot of times you tell me that you actually will want to do a lot of practice so that your math can improve. It is only true if you actually understand the concept. Okay, the practice actually help you in the algebraic manipulation, but if you don't understand the concept and what to actually how to start off the questions, no matter how much you practice, right, your improvement is going to be very easy. So understand the concept is the most important. Okay, so far? So this one no problem. So I can leave the simplification up to you. So you actually get the answer there. And the question later says, find the gradient of the tangent to the curve at t equals to 1 over square root 2. So basically, this question here is to actually sub 1 over square root 2 into dy dx. Oh, weird. Sub 1 over square root 2 into dy dx. So if you actually do the substitution, let's do it. I just do a bit of the substitution for you. This is a 1 plus e squared. So 1 plus half cube 1 minus half cube. So if you actually do the working out, you should actually get 27 as the answer. For those who try it, do you all get 27? Here. So 27 as the answer. And for those, yeah, any questions? Anything else? 1 over root 2. Oh, I already sub it. The t have a square, right? So square root disappear. Okay, sometimes I will keep steps. Okay? Okay, right. So I think for those who have tried the questions, I think the issue is this. The issue is the very last one. Correct? How do you actually get the angle between the two lines? Agree on? That is the questions that all of you should have if you actually try the questions. I believe the first two parts shouldn't have a problem. Okay, right? So how do you actually do the last part? Okay, so how do you actually do the last part is this. The last part, to do it, will be like this. Imagine that you actually have two lines. Right? Okay, I didn't actually put in the axis because I do not know where they are. At least I know they will intersect. Reason very simple, the gradient are different. Correct? Okay, the gradient are different. So this one is the tangent that you actually have. So I just write down the information that I just need. Gradient 27. You may ask me, I thought I actually need the whole equations. Maybe the whole equation is needed to actually to find the angle. Well, later you'll know. The gradient is the most important information. So gradient 27, this is the tangent gradient. Then the line that you actually want the tangent to make the angle with is y equals to x plus 3, right? Correct? Gradient is how much? 1, gradient 1. So I write down the information, gradient 1. Still following, you know what I'm doing, right? So basically that's the two lines. Okay, and the angle that you actually want, all agree the angle is this one that you want. Well, this is the angle that you want. Agree? Yeah. So how do you actually do this? Very simple. Let's imagine that there's a horizontal, imaginary horizontal axis there. And so far, yeah. If you can get me this angle, the green color one. You can get me this angle, green color one. Blue color come out. Okay. So green minus red will give you the blue that I want. Alright? So one thing to actually, okay, what is the key step to actually solve this part is this. Actually getting the red color one is very simple. Because if you think about it, if I actually want this red color one, go back to your secondary school, you will all do something like this, right? If, it's again if. If you have the opposite length, if you have the adjacent length, you can find the angle. Make sense, right? What trigo will you use? Tangent. Make sense, tangent. So tangent and angle is equals to opposite over adjacent, correct? But you already have the value of the opposite over adjacent. How much? You know? What? What is the definition of gradient? Anyone? Go back to secondary school again. What is the definition of gradient? How do you actually find gradient? You actually go opposite over adjacent, right? And that's the reason why the tangent has the name tangent. And the trigo, the tangent either has the name tangent. You understand? Yeah, because basically it's opposite over adjacent. It's actually the gradient of the line. Understand this? So to actually get this red color, which is, okay, let me call it theta if you really feel very uncomfortable. Tangent theta is what? Remember, this is the line that I'm talking about, gradient 1. And what is the definition of gradient again? Go back to secondary school, the way that you find gradient, opposite over adjacent, right? Agree? So gradient, opposite over adjacent is equal to 1. And to get the theta, it's just tangent theta equal to 1. Make sense, right? So if you understand this concept, how to actually get the green color angle? Tangent that angle equals to 27. 27, correct? So basically, you just do a tangent inverse 27 minus tangent inverse 1, you will get the answer that you need. Correct? So giving you the answer 42.9 degrees. Yeah, and this one, please take note, because this one came out for A level 1. And that's the reason why when we actually give this question, we actually modify from the A levels. Okay, so the important thing to take away from this last part very simple. If you have the equation of the line, from the value of the gradient, you know the angle that this line makes with the horizontal. I emphasize that, makes with the horizontal. It's basically what I'm doing. Correct? I repeat, if you have the equation of the line, the gradient, okay, the value of the gradient, okay, can give you the angle that this line makes with the horizontal. And the best thing is this, if let's say you have a line, let's say y equals to minus 2x plus 3, alright, what is the gradient in this case? Minus 2, right? Agree on? Minus 2. Then the thing is this, you go and tangent inverse minus 2, what do you actually have? You actually get a negative answer. But the negative answer is telling you that this angle is actually an obtuse angle. Make sense? And then you just do a simple adjustment, plus 180 degrees. You will get the angle that you want. Okay? So tangent inverse the gradient will immediately give you the angle that you need with the horizontal that the line makes with it. Okay, so take this away. Okay, this is the concept to solve this part. Okay, wrong? Oh, yeah. If you know, then I can go to the next one. Can? Any question to clarify about this first question? If no, go to the next one and try to solve it yourself. Okay, so question 2. All ready for question 2? Any question to clarify about question 1? Oh, okay, right? Students, oh, okay. Now, so for question 2, can I start? Okay, for question 2, very simple, please read. They give you all this information and they want you to sketch a curve. So basically, what you actually do is, you just key in the curve into the GC. Correct? And then, again, because of my habit, I will actually go to the window. Okay, please pause for a while. All agree that I am keying in the thing that the question actually wants. You do know sine 4 theta is sine theta everything to the power of 4. So please do not key in like what is actually appearing from the question. You have to do something like this. Bracket the whole thing up to the power of 4. Is this fine? Then because of my habit, as I said, because once I do a work with DC with a long time, I will know that before I sketch a parametric equation, I will go to my windows. Because why? I want to actually take note of my Tmin, Tmax. My question, in this question, right, anything to adjust? If so, how to adjust? My T minimum should be how much? 0, right? Because the minimum they actually give you is 0, so enter. Tmax. Students, Tmax, is it simple, right? Over 2. So you actually give a pi over 2, enter, then you will just graph it. It will be actually very small. So I do not know how comfortable you are with your GC. Maybe yes, you can do zoom in, but usually I would like to use zoom box because zoom box give me more flexibility in where I actually want to zoom in. So to use zoom box, you just move your cursor to one place, enter, form a box around where you like, then the curve will actually come out. Okay, enough. So usually I like to use zoom. Of course, it's a bit more troublesome. You actually have to open up the box. Okay. Now, one thing is this is your curve. Only thing that you need to take note when you actually sketch this curve is this. Yes, you actually do it like this. Sorry, I don't have a ruler. Please use a ruler when you're doing it. X and Y. Alright. And then you just do something like this, right? Correct? Now, one thing is this. If you actually do something like this, right? The question usually wants you to actually give me the axis intercept. Do you know how you actually can get me the axis, the actual intercept? Let me write down the value first. 2 sine 4 theta, comma, y equals to cosine 4 theta. This is what the question is asking you to sketch. Do you know how to actually get this actual intercept? Without the use of GCR. Because a lot of times, we are working with unknowns. It's actually good to know how to work with the parametric equations. So anyone knows how do you actually find the x-intercept? So simple, go back to basic. X-intercept means y equals to 0. So this is how we do it. Y equals to 0 leads to theta being 1. This is basic trigo. So y equals to 0 means theta is what? No one knows that. What is the angle that makes cosine 0? 1? No. Why? Pi over 2, yeah, thanks. 90. So once you actually have pi over 2, what do you actually do to this value pi over 2? You sub it to this, the x expression. Giving you? Students, giving you. Sine pi over 2 is, this awkward silence is very worrying. Sine pi over 2 is 1. Okay, to power 4, 1 is so 2. Okay, right. So this one, anyone knows the value? So very simple. To actually get the y-intercept, you make x to become 0. Correct? So x is 0 means theta is 0. So put 0 into cosine. Cosine 0 gives you 1. So this value is 1. Okay, right? Any issue with this? So any issue? So again, listen now. This is the part whereby a lot of students, and I must admit, including me, will tend to miss out. Listen very carefully. So just now when you actually find this point, you actually use the parametric value pi over 2, correct? When you actually find this point, you use the parametric value 0. Agree on? Read the question now. Is 0 and pi over 2 in the range that the question actually defined? Read the question. This is why I have to keep on emphasizing. You have to go back to the question. There is a lot of details inside. Go back to the questions now. What does the question say about the range of the parametric value? Read. 0 to pi over 2, right? It says 0 to pi over 2, right? Correct? But is it inclusive? One. Which means there is one thing that I need to adjust to my graph. The thing is, you want to hollow circle, correct? So you need to put a hollow circle here. You need to put a hollow circle here. Okay? Okay, these are details. Students at the top, all okay or not? So this is a graph. And after this, the question says tangent cuts the curve, cuts the x-axis at P, y-axis at Q. So show this, show that the dy dx equals to something like this. This one I just don't need to actually talk too much about the concept. You should know by now that in order to find the dy dx, I will have to do dx dt. sorry, not dx dt, dx dt theta. Okay, guys, okay. Listen, take note. Again, these are some extra things. Some of you actually have know it already, but I just want to emphasize it. Whenever I do the differentiation, right, in my mind or on my answer script, I will change a sine 4 theta into something like this. That means I will see it as a sine theta whole to the power 4. Reason very simple. When I do the differentiation, I will know how to apply my chain rule properly. Because remember, chain rule is the basic rule that you must always apply when you do differentiation. And chain rule to me very simple. It's like I usually tell my students like peeling an onion. That means layer by layer by layer by layer. So for these questions, when you differentiate, what is the first layer that you differentiate? Okay, when you look at the expression, you must actually know how many layers are there, and when you differentiate, how many times you actually have to do the differentiation. So when you look at this expression, how many layers are there? First layer. What is the first layer? Power 4. Is that the second layer? Sine theta. Understand this? And sometimes this layer thinking helps you to do your implicit differentiation. Because why? If let's say that now the variable is y, and you are differentiating real respect to x, and so for the layer, you differentiate the y, giving you dy dx. That explains why when you do implicit differentiation, the dy dx will drop out. Understand this? Here, so the differentiation will become something like this. Okay? Yeah. So your dx d theta is this. So I skip a bit of step. Your dy d theta will be minus sine theta. And one thing about differentiation is this. Once integration and differentiation start to come in, right, a lot of you will actually sometimes mix up. When you differentiate cosine theta, you actually have a negative. Correct? When you integrate cosine theta, you actually go back to sine theta. Correct? So sometimes this is where the confusion will actually arise. So take note all these kind of things. So once this is done, you just need to do a dy dx. If you do it, your working will look something like this. Well, alright. So you just do the simplifications, things can cancel off. You actually get cosine square on top, sine square below, hence giving you yeah. I do not need to show you the details in the working, right? Don't know what's going on. Okay. So once this is done, okay, show the coordinates of P is this. Okay, I need to actually show P and Q. All of you are still following me. I'm doing part 3 now. So in order to actually get the coordinates of P and Q, first thing first, I think you all agree, I need the equation of the tangent. Because without the equation of tangent, I can't do anything. Make sense? Agree, right? Agree? Yeah. So in order to get the equation of tangent, basically you just need to do like this, which is what I prefer, y minus b cosine 4 theta. Okay. You know what I'm doing now? Y minus y1 equals to x minus x1. Correct? Okay, and actually take note. Can you put down somewhere in your notes or the solution that you're copying down? When I actually do this, that's actually a substitution step that's involved. Because when you actually tell me that this is the gradient, you actually have to sub in a value for the parameter. You have to. Later, when you come to question 3, this will happen. But actually, why am I, when I'm doing this question, there is so-called no substitution? There is. It's just basically the fact that when I'm actually reading the question, right, they say that the point that I'm actually looking for the tangent is a sine 4 theta, b cosine 4 theta. So basically, the parameter is still maintained as theta. Understand this? Later, when you look at question 3, the parameter actually changes. So when it changes, you have to do the appropriate substitution. Understand? Okay. So once this is done, you can just do the simplifications yourself. I hope you are very comfortable with your trigo simplification. But if you actually don't want to do it, also fine. Because basically the question actually just want you to find the coordinates of P and Q. So for P, actually is when y equals to 0. So for P, which is the x-intercept whereby the tangent cuts the x-axis, you are setting y to be 0. So if you set y to be 0, basically you are just doing this. You are just doing this, and then when you are doing this, right, basically you are just solving for your x. Can remember one thing, this cotangent theta, okay, if you need one more step, the next step I will do is something like this. Okay, the next step I will do is something like this. Okay, right? Why? I will actually multiply that expression, this expression over the other side. Okay, right? And you do know cotangent is the reciprocal of tangent square. So when I multiply over, it becomes tangent square. So tangent I just split. Why? I want to cancel off sine and cosine. Okay? Here, I want to cancel off sine and cosine. So after you actually do this, right, this will become a cosine square theta, sine square theta equals to, okay, I shift this over. Is that a negative value? Okay, cannot. But the thing is this, the question actually, the question actually gives you the answer for the coordinates of P. They say that the x value is a sine square theta. Does this look anything like a sine square theta? Alright. Do you know how to simplify to it? Okay, if you don't even know how to, it's simple, just continue. Means you can factorize out. Correct? So you can actually factor it. So what is the thing that you can factorize out? A, you can factorize out. Anything else? Sine square, right? As you do this, you will discover that the things that you are left with is something like this. And you know cosine square plus sine square, giving you 1. So your x value is a sine square theta. This one's fine, right? So this is the idea of the simplification. If you do the same thing for your Q, point Q, whereby you sub x to be 0, you can carry out the working yourself. Okay, you will actually get the answer for the Q to be 0 b cosine square theta. Students, listen up. I'm skipping step again. Okay, I already show you the working for P already. Yeah, the simplification. You will have the same simplification set when you are finding Q. Okay, everything will be the same. Then you will actually find that the y value is b cosine square theta. Any issue? No. Yeah. So I solved the 2 points for you already. Is this fine? Okay. So if you are okay with this, the question actually says that I will need the, let me see, the area of OPQ. So picture why it looks something like this. This is P, this is Q, this is O, triangle, correct? So I think you all should know that my area should be equals to half a sine square theta b cosine square theta. Agree? Agree? That's simple, right? Agree, right? Now, what is the next thing that the question actually wants you to do? The question says that please find the value of A varies as theta varies between 0 and power 2. Determine the actual value of theta which A attains maximum. When you see this word, maximum, what is the thing that comes to your mind? I will need to do differentiation. If my expression is something like this, okay, my expression is something like this, my differentiation will be dA theta. After I do my dA theta, what will I actually do to the dA theta? Equals to 0, correct? Okay, listen out, students. I need you all to actually have the steps, okay, in your mind when you are doing min-max question. You will differentiate. You you will set it to be 0. You will find a value, correct? There is one last step actually that you have to have when you are doing min-max question. What is that step? You have to check whether it's min-max. And actually, my advice to you is this: do not do the second derivative, because expression sometimes is very complicated. My advice: do the first derivative. You know what I mean when I say do the first derivative? You create a table. You say the value a bit less, a bit more. Okay, never mind. I will show it to you. Although the question never asks you to do it right, I will show it to you. Reason very simple. That one right, you can fake it out. Yeah, you can fake it out. Okay, so how do you so-called fake it? It's not fake it out, it's actually correct. It's just that you can fake it out. So, listen, so I'm going to show you the whole step. Even though the question never asks you to show it's a maximum. Listen, before I do anything, what will you actually do if you see a sine theta multiplied to a cosine theta? You need to have this trivial identity very fast in your head. A sine multiplied to a cosine. Does it look familiar to you? Yeah, a formula. Do you all agree that sine 2x is equals to 2 sine cosine? Correct? Which means that this whole thing here will simplify to this. Reverse. And there's a reason why I want to do this. Because if I keep my expression like this, we'll agree that if I do the differentiation, I have to do product rule, which is complicated. If I change it to this, we'll agree that it's just normal chain rule and answer come out. So I understand sometimes why when you do certain things, the whole working becomes very long. Your friend do a certain working if it's so short. So sometimes it's your algebra manipulation skill that come to your help, or I don't know, hinder you. Yeah. So when you actually do it like this, if you do the simplification, I think you will have something like this. And the differentiation becomes very simple. It's just dA, d theta. Okay, there's nothing. It's just 1 over 8 AB cosine 2 theta. Then you differentiate the 2 theta again. Is that square? Oh yeah, that's square. Sorry. Okay, so let me do it again. 2 sine 2 theta. Correct? Is it correct? Can? Yeah. What's all of this? Okay, again, if you can't see it, I write this like this. So again, it's layer differentiation. I repeat again, layer differentiation. Chain rule is layer differentiation. So when I do this differentiation, how many layers are there? Power 2. Second layer, sine. Third layer, 2 theta. Okay, 2 theta. So you will see all my differentiation there. Make sense? Students, okay? Yeah. And once you do this, you have to set this to be 0. Agree all? So when you set this to be 0, I think all of you can agree, right? It's either sine 2 theta being 0 or cosine 2 theta being 0. Make sense? Now this one, if u theta equals to 0, can I accept this? Every time when you read a question and you see whether or not I need to accept or reject a value, go back to the question. Can theta be 0? Read on. You read the question again. Theta is strictly between 0 and pi over 2. So this one out. Make sense? Make sense? Correct? Then the thing is this. This one will have an answer. You know what the answer is? Cosine inverse 0 give you what? Give you, okay, 2 theta give you 0, 0 and 1. You know, it's pi over 2, sorry. So implies that theta is pi over 4, right? Correct? And then after you sub pi over 4 inside, you will get the maximum area. The substitution I leave it out to you. You will get AB over 8. But I want to show you how do I so-called fake the table out. Let's say that the question now wants you to show that it's actually maximum, correct? Don't differentiate it. Because sometimes the differentiation, the expression is very complicated. What will you do with this? You already know that this is the answer, correct? So this is the way you do it. Look at this, how you test out first derivative, right? You say that power 4 is the value of your min-max point. You find a value that's a bit less. So how to actually express it? Pi over 4 negative on top. a bit more powerful part on top. Then the thing is this, dA d theta at this minimum point confirm 0. Make sense? Then already, the question says that this is a 1 point. Maximum, right? You don't even know whether it's positive or negative. Very simple. Draw a very big, simple picture. Maximum look like this, right? Right? You don't even need to sub. You want to sub, go ahead. Okay, but usually in exams, no time. I'm not faking. I'm just doing a very fast calculation. This is the thing. Yeah? Understand this? But again, this working have a problem. If your answer is wrong, everything, people will know that you cheat. Is that right? Okay. So, I leave up to you. Can So, if your answer is right, this thing can fake out. It's not fake out, it's correct, it's just writing out. Okay? Yeah? But for those who are actually still doing second derivative, I'm not preventing you from doing it. You can continue to do it, but you need to be fast. Okay? Understand? So last step, there's a last start part. You just need to sub in. Repeat, I again skip that. You need to sub in theta to be power 4 into A, giving you AD over 8 for the answer. Can I move on to question 3? Yeah, right. Okay, let's go. Okay, question 3. I'm not going to do anything. Okay, listen up. dx dt, dy dt. Okay, listen up, students. Question 3 is given to you. I repeat, you do not actually need to remember the formula for differentiation. But then if you look at question 3, there seems to be an issue. If you look at the two expressions, x equals to secant t, y equals to tangent t. Tangent t, differentiation no issue, right? But you actually do dy dt. Answer, students? When you do this. I'm asking you for the most simple one. You differentiate tangent, giving you secant square. This one very simple. But when you differentiate secant t, correct? Do you actually need to remember it? No. You just need to go to your MF15 and then check the formula for the differentiation. The sine x, the secant x is there. So I repeat. The thing that is required from you from secondary school is the differentiation of sine, cosine, tangent. If there is not, okay, if the question is not asking for these three things, it should be in the formula list. Understand this? So no memorizing work needed. So if you actually differentiate secant t, you actually get secant t tangent t. Understand this? Yeah? By the way, you know what are the things inside your formula list or not? Okay, these are extras. I just go through again. What are the important things to pick it up? Okay, this is the formula list. You just put down somewhere. First thing first, this formula. N choose R is inside. But N choose R is not under probability. It's on your first page. And then this is N choose R formula. And for certain A-level questions, you need to do it. Okay, you need to do it. There is 1 year, they actually ask you to have it. All this formula is for what? All this formula is for Maclaurin series expansion. Do you remember Maclaurin series expansion? Okay, I'm going through quickly with you. This one is your partial fraction. But I hope by now, partial fraction, you don't need the formula to do it. This one, all the trigo identity. I repeat again, what are the users? Listen, just listen. What is this for? This one is for you to split. If you have sine and cosine multiplied together, you can split it into addition or subtraction between sine and cosine. This one is the more important one. The rest, I think you will memorize it from the work that you have done in secondary school. Differentiation formula, integration formula. Understand? Everything is inside. Okay. Then of course, behind is all the statistics. And so on. Okay. So this one is sine t. Sine t what? Tangent t. Thanks. So dy dt is equals to, if I do the thing is like this. I have a question, students. Can I simplify further? For this one, can I simplify further? How? Okay, if you cannot remember, just change it. Yeah? And you just change it to sine and cosine. And it will become cosecant t. Make sense? Okay. And again, it's getting repetitive. So for part 2, I will just work it out. But take note of my working, students. Should I write it like this? Listen up. Following what I have been doing for the past two questions, should I do it like this? Y minus y1 equals to the gradient multiplied by x minus x1 secant t. Is there any issue in my working for this particular part? Read the question again. Again, I want to emphasize this, must always go back to the question. Is there an issue? Yes, no. Yes, no. But what is the issue? Anyone know what is the issue? If I present it like this, actually if I present it like this, I will be marked down. I will lose marks. What is the problem? You have to read the question. What is the problem? The question actually asks you for the tangent at where? Okay, I go back to the question. The question actually asks you for the tangent at where? You're right. Agree? Do you see that if I'm actually talking about this point, the value to the parameter has changed. It has changed to t to what? Theta. Agree, theta. Which means that when you actually find this gradient, it's no longer cosecant t. It's actually cosecant theta. And this is what I mean by when you actually want to actually put in the value of the gradient, right? There's actually a substitution step involved. I want to emphasize that there is a substitution step involved. Question 1 and 2, why you didn't say it? Because the parameter never changed. Understand this? Okay, if you work, because I've seen a lot of my students working, they always take dy dx as a gradient. No, no. dy dx is not the gradient. I repeat, dy dx is an expression for you to find the value of the gradient. It's only when you sub a value inside, it will give you the value of the gradient. Understand this? dy dx and gradient are not the same. Okay? So this one, theta. So let's simplify. Okay, this one. You look something like this. See my working. Okay, so I will do simplify. Theta, so on top is 1 minus sine square theta. Okay, pause for a while. I stop until here. Don't copy blindly. Are my sign correct? Is the negative positive sign correct? I pause again here because this is the part a lot of you will make a mistake. Am I correct? Okay, how do I actually do the simplification? Because I see this as sine theta over cosine theta. Correct? I make it into common denominator, sine theta, cosine theta. Okay? So I bring it up. I have to bring it up. I combine everything. But take note, this negative sign seems okay. But then, suddenly, right, from plus, I just happily change it to minus. Am I correct? Yeah, from plus I change to minus, right? You realize? Is it correct? It is. Remember, a lot of you will put this point as plus, this sign as plus. Because when you do a combination, you forgot that when you actually combine everything and the sign outside is a negative, technically, then it's a big bracket that you have put outside. When you put a big bracket outside, sign changes. Okay, negative sign is the most problematic thing. Okay, it will cause a lot of chemical. So when you're working with negative sign, please be very careful. I pause. Okay, please think, I am correct. But a lot of you, I want to emphasize, yeah, I'm correct. I'm looking at the answer. It's not that I'm good. I'm looking at the answer. Okay. So this one, and what I'm saying is, a lot of you will put plus. A lot of you will put plus. Take note. When you are doing your own revision, please take note whether you have this kind of mistake. If you have it, my advice is start to put in bracket to help you. So this one, do it. This one will simplify cosine. So I did sorry. Let me double check. Sorry. Is it? Why so nice? Oh, sorry. What am I doing? Okay. Is it okay? 1 minus sine square cosine square, cosine square cancel with cosine. Yeah, a lot of trigo involved. Okay? Okay. Okay, listen up. One thing is this. It's going to be 11:10 soon. After these 3 questions, we'll take a 3-minute break. Then Mr. Ma will take over me. Yeah. For 4, 5, 6. So listen up. Read the question. Listen, guys. Listen. Read the question. If you read question part 3, all of you, are you all confident now in solving it? Part 3. Guys, part 3. All confident in solving it? Yeah, right. Because it's basically finding the area of the triangle. All of you, are you all confident in solving it? Yes, sir. Can I actually move on to part 4, which is the main issue? Part 4. Already? Part 4? Okay, part 4. Okay, part 4. Students, I repeat, I skip part 3. For part 3, I think you all know what to do. Now for part 4, before I start, I need to know the coordinates of A. I need to know the coordinates of B. How do I know these 2 points? Just now, when you are doing part 3, let's say that I leave part 3 to you, you will actually have to get these 2 points before you actually can find the area of the triangle OAB. Make sense, right? So these 2 points are there. That's all? Okay. So, listen up. I have these 2 points, but why do I need these 2 points? What does the question want? Find a Cartesian equation of the locus of the midpoint of AB at intervaries. That's the question, right? So very first thing, what do I need to find first? Students, what do I need to find first? The question say midpoint, right? So should I actually go for the midpoint first? Right, midpoint. Do you all know how to actually get the midpoint for AB? Okay, midpoint I call it M. What's the midpoint? Students? Hey, someone, this one should be simple. What's the midpoint? Cosine theta over 2 minus cotangent theta over 2, right? You know how I get it, right? It's the x coordinate add together divided by 2. Add. I emphasize against add. You can't see it here because one of the values is 0. Okay? So how do I actually get the midpoint? You add the x coordinate together divided by 2. You add the y coordinate together divided by 2. Okay? This is the midpoint. We're not done yet. Because midpoint. But the question actually wants you to ask for one thing. Equation in Cartesian form. Correct? Equation in Cartesian form. Make sense? Students? How do you from here give me the Cartesian equation? Think about it. How do you from here give me the Cartesian equation? Well, Cartesian equation has to have what inside? Okay, why? So how to start off the very first step? Well, I think I do it like this. Can be done. Because after I find this midpoint, the x coordinate is cosine theta over 2, the y coordinate is minus cotangent theta over 2. Make sense? But the thing is this, I want a Cartesian equation. At the end of the day, that equation must only contain what? X and y. So there's one thing I need to remove, right? What is the thing that I need to remove? Theta. Make sense? However, take note. When you study parametric equation last year, the way that your teacher teach you is how to actually remove the parameter is a lot of times you make the parameter the subject, right? And then you equate together. Then the y and x will go. You can't do this for trigo. Okay? No, not for trigo. So how to do it for trigo? Very simple. How to remove the theta if the theta is inside the trigo expression? You think of trigo identity. Understand? So how do you actually think of trigo identity? Okay, let's do something first. Let's this 2x first. Because I know that I have to use trigo identity to remove the theta. So I make all the trigo the subject. So that's good. Yeah. But this is not good enough because from the way that I remember my trigo identity, there's no one identity that link cosine and cotangent together. Agree? Okay, because cotangent, listen now, this is again classic. Cotangent is linked to what? No. Cotangent, I mean trigo identity. You know something squared plus something squared equals to 1, 1 minus something squared equals to something squared, those trigo identity. Remember? So what is, okay, cotangent is linked to what? Cosecant. Okay? Tangent linked to secant. Understand? So I don't see the link here. So what do I do? Any advice? Triangle, well, you see, just now I mentioned already. Tangent linked to secant, right? Secant is what? Cosine. Do I see cosine here? What do I do? Just flip off. Make sense? Make sense? Can I square it? Well, and the expression is 1 plus tangent square theta equals to secant square theta. Agree? And some of you will say, sometimes I find it difficult to memorize all these trigo identity. Okay, don't need to memorize again. If you haven't known this, all of you is very comfortable with this, right? Right. So to get the other trigo identity, either you divide everyone by cosine square, or you divide everyone by sine square. You will get the one with cotangent linked to cosecant, you will get the one with tangent linked to secant. Understand this? No memory work here. So with this done, you will be able to put in the values here, and then this will be your Cartesian expression. You are done. But again, the answer, right, there is some details that you need to include in the answer, because once you actually do this, if you read the questions very carefully, there is a condition on the theta. Can you see, right? 0 to pi over 2, correct? The problem is, if t is between 0 and pi over 2, if you put it inside here, your x is between 0 and half. Your x is between 0 and 1. Okay, 0 and 1. But the problem is that when you actually find this midpoint, okay, how should I say this? Okay, when you find this midpoint, right, we agree that this x here is this value here. Well, this x is that value there. Correct? The question tells you that your theta is between 0 and pi over 2 at the very start. Agree? Agree? The parameter value. Is that all? So if it is between 0 and pi over 2, cosine theta is between what? You all know? 0 and 1? Agree? 0 and 1? Because it's in the first quadrant, 0 and 1. And divided by 2 is actually between 0 and half. So there is a condition for x. In this case, your x value is between 0 and half. You have to put this down, okay? Again, if let's say in an exam you don't see this, it's fine. At the end of the day, the most important thing is get me the Cartesian equation. Then again, why do I actually need to put in the condition for y? Well, not necessary, because once I know the range of the x, okay, y is automatically taken. So this one you don't need to give it. Okay. Again, if you can't see this, to me it's fine. The most important thing, how to get Cartesian equation from parametric. Okay. So what is the thing that you have learned? If it's not trigo, very simple, make the parametric the subject equate. If it's trigo, use trigo identity.
Okay, today we will start the question 4. I'll continue from question 4. So the question 4 is about maximum minimum question. So normally your approach this question is go by this procedure. There are 4 steps you can do the maximum minimum. First one, let's see, you write down first. Formulate. Next one, minimize your error. Next one, I'll explain to you later. PV differentiate, or the a dx. And number 4, you just make it 0. You solve it. And number 5, you will solve it and you sub back. And number 6, you will just like justify whether it's maximum or minimum. Okay, I'll look at this question. Now this question is about cylinder inscribed into a cone. So let's draw the diagram. So 2D. So here we have this dimension. You see the cylinder dimension is small r. The cone radius is r, capital R. Then the height is 8. Then of course this height is 8 minus h. Now we need to take advantage of now let's say we need to do formulates. We need to see this question is a maximum curved surface area of the cylinder. So of course the first step we will formulate. So I'll formulate the area is, okay, I will define this as h. Okay, this is the cylinder height is h. So a equal to 2 pi r h. Now this is step 1. We formulate. Now we got problem because we have r and h. We need to minimize. So we need to take advantage of some geometry, the similar triangle. So you have, based on the triangle, so 8 minus h over 8 equal to r over r. Okay, so from here we make, because this question they want us to prove the in terms of small r, so it's good we have find the h in terms of r. So 8r over r, we can get h equal to 8 minus 8r over r. Okay, so now we're ready to do the second step, minimize the variable. So now you sub back into the a, it's going to be 2 pi r, h you change to 8 minus 8r over h. You simplify, you will get the proof part. Okay, you get the proof part. The next step we're going to do step 3. Right, we minimize variable. Step 3 we just differentiate. Because they ask you the maximum, so you say differentiate the r equal to 0. Remember this equal to 0. So you will get the 16 pi minus 32 r pi r equal to 0. So you can find, you can cancel the pi, you got r equal to half r. Okay, then you sub back. Okay, now you need to do the number. Yeah, number 4 is done already. Number 5, sub back. So you sub back into the a is 16 pi. Sub back here. I need like the r over 2 minus 16 over r pi r over 2 square. Okay, then you get the answer. You get a equal to 4 pi r. Okay, then last minute you need to justify. So for the last step, justify. Remember this box and then this box. Okay, so here it should be small r, here should be dr. So this is capital R over 2, R over 2 plus, R over 2 minus, and we know this maximum, so we go on them first. Now of course we can see, oh, this is positive, 0 is negative. Okay, this is therefore maximum a when r equal to half r. Okay, so we're done. So this kind of question is very classic. You just remember, reflect on. Just remember, it's always this frame 1, 2. You formulate, you minimize, you differentiate, then you solve, then you sub back and justify. Okay, so this kind of question is always like this. Now, question 5. Also very important. Question 5. The problem is you see this cone. out the water. Okay, so we just introduce, let's say I call this the R, let's call this the H. So this here, this total is 10. This bottom is 3. Okay, so we did 3. So here, this one should be 10 minus H. Okay, and 10 minus H. So we can use the similar triangle. 10 minus H over 10 equal to R over 3. So we can find R in terms of H. Okay, in terms of H. Then, now let's stick to the frame. For this kind of question, always stick to the frame. Because the top rate of change is normally dv dt equal to dv dh. Okay, they always like give you 2 out of the 3, you find the third one. So they already told us the, okay, but of course we need to find dvdh first, because we know dvdt, we have to find dh/dt, so this one is better to find out. Okay, so find dvdh. But of course, before find dvdh, you must formulate the v into the h. So v is equal to, now don't forget this v actually is this is the v, the bottom part. So v is going to be 1/3 the big cone minus with the small cone, small r square h. Okay, this h is 10 minus h. Okay, 10 minus h. This small h is 10 minus h. Okay, so you can write v equal to 1/3 pi 90 minus, not 1/3 pi. You'll be good, I will write in terms of h only. So this r, we will try to write in h only. So it's going to be 30 minus 3h over 10 squared 10 minus h. Then you will just simplify. V equal to 1/3 pi 90 minus, okay, so it's 3 pi over 100, then 10 minus h cube. Okay, now we're ready to do the frame. Okay, for the frame, dv dt equal to dv dh dt. Okay, so I'm going to sub in the dv dt, which is 3 dv dh. Now you need to dv dh. Let's do the over here. This one disappear. So minus 3 pi over 100 copy. Then the 3 bring down, then minus h power 2, and time minus 1. Okay, so it's going to be minus 3 pi over 100 times 3 and 10 minus h square time minus 1 times dh dt. Now, because now they tell us the h is 5, is sub h equals 5. Okay, good. So we can find, so 3 equal to minus 9 pi over 100. Then after that, 10 minus 5 square minus 1 dh dt. Okay, so with now you can find the integer. So we can find equal to 4 over 3 pi. If I'm not wrong, so be cm per second. It's decreasing. Okay. So this question of the procedure will be used, or again try to establish a relationship between r and h, also like minimize the variable. Then you have dv dt, dv dh, dh dt, all this. Then you based on the formula. Please remember always reflect because sometimes question can be different. So this one, you okay? Let's move on. Now, 5e, I can show you the method. If you can just factorize, you'll be looking like this. But I want you not every time you can factorize like this. Not every time you can do like this. So it will be this one. P, we have this. differentiate because they talk about the tangent, right? Whenever they talk about tangent, just differentiate. So dy dx equal to minus x or dy dx equal to minus 2x. Now they tell you at x equal to c, so your dy dx is equal to minus c or dy dx equal to minus 2c. Okay, so with that we can find the tangent. Okay, now when x equals c, we need to find the y. When x equals c, y equal to minus c squared over 2 or y equal to minus c squared. So there are two values now. Then we calculate the tangent, right? Or because they say oh, this question no need, because they say the tangent parallel to this line. Okay, the question says tangent to this one. So this one times equal to half. So straight away we can see minus c equal to half or minus 2c equal to half. So from here we can say c equal to minus half or c equal to minus 1/4. Okay. So this is the fast way. Of course, this is the fast way because if you can spot from beginning, you can factorize. Then you make your life much easier. You can just differentiate and sub in the value you equate to the tangent. Of course, or the conventional way is a bit more tricky. It's going to be like this. The conventional way is just differentiate implicitly. Like 4 plus 2y squared plus 3x squared y equals 0. So we differentiate implicitly with respect to x. Okay, then you're gonna have 3x. Then you have 4 3 plus 2 times 2y dx plus, okay, this one is UVR, u dv plus v du equals 0. So from here you can find dy dx in terms of x and y, so which is minus 6xy minus 4x cubed over 4y plus 3x squared. Then from here you sub in x and y, but unfortunately we only know x equal to c. We need to find solve y. Okay, so solve y, you need to sub x and c into original equation, which is c4 plus 2y squared plus 3c squared y equals 0. So from here you solve the c. Okay, so you solve the y, so 2y, y factorize again, so y equal to half c squared over 2 or y equal to minus c squared. Then you need to sub in x and y into the dy dx and solve the thing again. Okay, you go back and try the rest. Now I'm gonna do 6. 6 is very troublesome. Fix, you need to use your GC. Okay, you need to use GC. Now when you plot the parametric graph, you always remember to use the parametric mode. So you go to the mode, parametric. Okay, for the parametric mode. Okay, then you can key in. Okay, e power t, then cosine t. Okay, then same thing for y, e power t, and sine t. Okay, sine t. Okay, now for this one, you're gonna be very careful. You need to change your window because they say from minus pi. This is very important. From minus pi to pi. Then the x minimum, let's make it bigger. When x maximum, make it into 10. Then y minimum minus 5. Negative 5. Okay, that's it again. Oh, still not enough. Okay, let's change a bit. Max minimum to minus 30. Maximum is okay. Y maximum to 10. Okay, so we press the graph. Come on, like this. Okay, so this one, the original 0 there is a bit fishy. I think we better zoom in and see what's going on. You zoom in this portion. What's going on? Okay, because we need to see what's going on here. Okay, see? Enter. Ooh, okay. So you're going to have like the portion looks. You zoom in some more. You see here. Okay. Okay, you see? Oh, okay, so you go like this. Okay, roughly we know how does it look like. Okay, so this graph, if you refer to it, you see, it's going to look like this, okay. It should be look like. Okay, so you need to find this point. So this question wants you to plot the graph. You need to get all the x intersect. So that is very, very troublesome. So now your job is to make x0 to find the y, make y0 find x. So basically you roll out 3 go. Let's do one by one. So let's make y0. So let's make y0 become ut sin t equal to 0. So ut cannot be 0. So sin t equal to 0, t equal to minus pi 0 pi. I mean we need to pair the range of t minus, so we have this t value. So t equal to minus pi, and x equal to minus e from minus pi. Yeah, you can just sub into the original x equal 0, x equal to e from 0, which is 1, t equal to pi, x equal to e minus e pi. Okay, so based on here, we will plot. Okay? So now we should know this point with minus e minus pi. This is minus e pi. This point is going to be 1. Right? Okay. So now we need to find the y intersect. Same thing. We need to write x equal 0. So you got e t cosine t equal to 0. Same thing. So we got cosine 0, we got t equal to minus pi over 2 or pi over 2, right? So now we need to stop in one by one. E equal to minus pi over 2, y equal to e power minus pi over 2, so minus 1, so it's e power minus pi over 2 negative. Just up into y, just up into y. Then we can e power minus pi over 2 and 1, so e power pi over 2. So we can sub into the, so this point is going to be minus e power minus pi over 2. This point is going to be e power pi over 2. Okay, so up to here, finish. 5 points. Then the next part. Next part we see the second part. Second part we say find the equation of tangent to gradient. Okay, so let's differentiate first. We need to find dx dt. It's going to be k in front, differentiate behind, k behind, k in front. Same thing for y. You keep in front, differentiate behind, plus on, so of course the area x, so it becomes et bring out nt plus nt, et bring out. Okay, and then we sub in the value when because the question says when t to the power 4, the particular point will be at x t to the power 4. Okay, I have like this can cancel. Become cosine power 4 is all this value. Cosine power 4 is 1 over 2 over 1 minus 1 more. So this one go to infinity. Okay, if the area x go to infinity means implies your tangent is vertical line. Okay, if you go back to the graph, actually it means that this particular point is point P. Okay, this is point P. Now the vertical line is x is something like we need to find vertical gradient. So we sub in t equal to power 4 into the x. Let's say the equation of represented x equal to e power pi over 4. Cosine power 4 is 1 over 2. That's all. Okay. Now number 3. Okay, number 3. They say the for this for a long time, so it's something like this. Right? This point P. Okay, this point P when t to the power 4 is subbing, it becomes e power pi over 4 over 2. Then e power pi over 4 for sine, cosine, all equal to 1 over 2. Okay, so this is the O, this is the P, so you can find actually this line is y equal x, because your xy coordinate is the same, so it lies on the y equal x. Then the question says there's a q also on the curve such that POQ is pi over 2, so OP perpendicular to OQ, and they say OQ to make an obtuse angle with positive x-axis. Obviously for this case Q should be here. Okay. Okay, so if this gradient is, if this m1 equal to 1 and this is m2 should be minus 1 now. So actually implies this equation is y equal to minus x because gradient is minus 1. Okay, so OQ y equal to minus x. Then of course this Q lies on y equal to minus x and at the same time at the curve. So you Q also on the curve, so you sub in x and y of the curve into this equation, so it becomes et sin t equal to minus et cosine t. So et obviously not 0, so you can very simply cancel. Tangent t equal to minus 1. Okay, tangent t negative second fourth quadrant, so t equal to second quadrant and t equal to fourth quadrant. Okay, now we need to check which one is certified the Q. So let's check when t equal to fourth quadrant, maybe the problem. And you should know Q second quadrant now. So second quadrant the coordinate should be negative, positive, right? So let's check. So your x equal to e power negative pi over 4, then cosine minus pi over 4, and this is positive value. Because cosine minus pi over is positive, e power over 4. So we cannot reject. Because x positive cannot be in second quadrant, so t equal to 4 reject. So obviously Q t equal to 3 power 4 is certified the Q. Okay, so your Q point will be e power 3 pi over 4. Cosine 3 power 4 is negative 1 over 2. Then of course the y value should be the positive value. So this is the Q. Okay, now after that, let's take one more portion. You see the area of POQ. Okay, let's write the graph again now. Okay, so point P is here, which is e power pi over 4 over 2. Q is somewhere here. This is O, this is P, this is Q. Now Q is this point. Q is e power 3 power 4 or negative 1 over root 2 e power 3 power 4 1 over 2. Okay, so now we know all this. Then we can find this triangle. We can use the half time base time height method formula. So we will triangle OP equal to half times OP times the Q. So the OP is very troublesome. OP is this thing, this x squared plus it's the same square times OQ is the same thing. Okay, so we can simplify like half. Now actually we're using this concept. We're using this concept, square root a squared plus, if a is positive for this case, so it's root 2a. We're using this. So here actually it's root 2a. This is the same. Then the other one, the second part is actually also root 2, we'll take the positive one. Yeah. Now after that, you can cancel. So also will be half e power pi. Okay. With that, you can reflect. This question is not easy. You have to really be careful about where do you find the corresponding t value, corresponding x value, y value, and especially the graph, this graph. And you need to pinpoint the q, because q, if you got wrong, q could be this side also, right? Because this side also can be q, also 90 degree, but it's not the one we want. Read the question carefully. They say is second quadrant. Okay, with this I think this question should be okay.